Phase transition is a drastic change in the behavior of a system. So you know a few of them, for instance, when at 0 temperature, water becomes ice. This is a phase transition, a change of the system. That's, but ice, I mean, the transition between ice and water is just one example. There are many other type of phase transitions in magnetism for, between water and gas, for instance. And the area of research that I'm currently in is actually studying the different types of phase transition, what can happen at a phase transition. So the Ising model is one typical model of statistical physics, which is intended to explain the phase transition that occurs in magnets. So at some point, if you heat a magnet above a certain temperature, which is called Curie's temperature, just because it was discovered by Pierre Curie experimentally, above this critical temperature, a magnet stops being a magnet somehow. It stops being attracted by, magnetized. So the Ising model was a mathematical model, a physical or mathematical model intended to explain this phenomenon. Well, the question is a little bit what you mean by a mathematical theory of phase transition, because, if phase transition proved anything in physics, was that actually it's a very, very wide phenomenon that happens everywhere, basically. So when you speak about a phase transition, theory of a phase transition, then, well, it depends which type of phase transition, in which type of systems, and so on. So on part of the theory, mathematics now understand pretty well what is going on. We even, in some cases, just, catch up with physicists, which usually are a little bit in advance, compared to us. But in other areas, we are completely blind. We are just at the beginning of the story, and we don't really understand what is going on there. So it's a very rich area, and I don't think that we are close to the end. We are rather at the beginning.